Thanks to Ian Cassidy and the Chile Explore Group for the opportunity to present a talk on the Onto copper gold discovery in Indonesia. This is a fabulous discovery and one of the largest porphyry copper discoveries in the past several decades, and potentially an important project to increase Vale's copper production in the future. These are my co-authors, our Vale team, who was based in Jakarta, and also some working out of Australia, and our local team of Indonesian geologists. We'd like to dedicate this talk to Peter Winterburn, our chief geochemist, who many of you may know as he spent a considerable time in Chile. And he was our chief geologist at the time of the discovery, but was unfortunately tragically killed last year in June. This photograph actually is a good opportunity for a quick introduction, as this single section of core provides a quite good summary of some of the most salient features of the deposit that I'll describe in this presentation. The photograph shows a core interval grading around 3% copper and 1 gram per ton gold. It's in an early intermineral porphyry, as you can see on the top portion, with an intense quartz vein stockwork, a dark quartz vein stockwork shown in this slide, with 1 to 2% disseminated copper as covellite, shown here in these brownish, blackish sort of purple areas. And as I said, unusual in that all this is contained within intense quartz porphyry alunite alteration in this case. There's also covellite occurs in the central piece. All this dark blackish material here is covellite. Occurs with massive pyrite and native sulfur as veins and replacements, again indicating a very high sulfidation state and indicating some addition and remobilization of copper and gold into the system at this later stage. So that's a bit of summary of what I'm going to talk about in this talk. This is a disclaimer referring to some of the forward-looking statements I might make and some definitions regarding resources that I'll use. You can have a quick read of this later. Since 2006 and before that through INCO, Vale has had a long presence in Indonesia and has explored for nickel and copper gold from the early days when PT INCO developed its Sorowako nickel laterite deposits in Sulawesi in the 1960s, right through to the present day. However, in January 2009, we had a bit of a change in strategy, and Vale decided to try and focus all our copper gold exploration in advanced argillic alteration lithocaps, as we felt these systems, although common in Indonesia, were poorly explored. But when exploration is successful in these, there is a potential to preserve the intact high-grade upper portions of copper gold systems, as I hope to show you. One of the first projects we looked at actually was the Huhu project. It was a 7th generation contract of work in Eastern Sumbawa, owned by Eastern Star Resources at the time. This is the outline of the contract of work here in Eastern Sumbawa. So that's on an island just east of Java, Bali and Lombok, if you know Indonesia. And then also for reference here is shown the Batu Hijau deposit in Western Sumbawa that was developed by Newmont, and also an advanced project called Elang, also in Eastern Sumbawa. And then the other thing of reference in this figure is the massive 7-kilometer wide Tambora crater on the top of Tambora here, which last erupted in 1815. This map shows the outline of the contract of work at Huhu. It covers about 192 square kilometers, and it's just outlined on topography. And it's also shown as the eventual outline projected to surface of the Onto deposit that I'll describe. And also here in this yellow dot, the Humpulao East, which was an early discovery on this project in 2011. The cow is owned currently by PT Sumbawa Timah Mining. The shares are owned by Eastern Star Resources, which is a Vale international subsidiary, and then 20% by Nika Tangbang, a local Indonesian company. The cow was explored between 1995 and 1997 by Aberfoyle, and they conducted exploration over the entire project area with nearly 5,000 surface samples, fixed wing magnetic survey, as well as 11 drill holes. And the best intersection was in this hole shown here, number 3. in the central part of the project area with 106 meters of 0.14 copper and 0.08 grams per ton gold. And then for reference, the Aberfoyle holes are shown in crosses, and then the later valley drilling is shown in the small dark circles here. What really attracted us to this project, other than the clear indications of porphyry related mineralization, was the large area advanced argillic alteration with quartz alunite dickite and extensive silicification. And this is shown by this hatch pattern in this area here. And in fact, that hatched area is mainly the areas of silicification and buggy residual quartz. And the quartz dickite and quartz alunite alteration is actually far more widespread than is shown by that hash pattern. This is the Onto area looking to the northeast, and these small white patches are actually small areas of advanced argillic and argillic alteration that in retrospect represented the sort of northwest portion of the Onto system exposed in this prominent Wadabura Valley. So the majority of the drilling was actually located about a kilometer to the east of here, so the right-hand side of this photograph, where the topography locally goes up to around 700 meters, and in fact the terrain goes up to about 1,000 meters in the background of this photo in the central part of the cow. For reference, this is one of our old sites. This is the old Wadabura camp down in the valley here, and you probably can't make it out very easily, but these sort of orange tarps up in this area would be one of the drill sites on the northwest side of the Onto deposit. As you can see, the topography is steep. In fact, it's much steeper and much more rugged than is indicated here. And all the work and all the drilling was helicopter supported. And as you can see, this area is intensely jungle covered. So on to exploration, and you'll see a fairly standard approach in here with essentially some geophysics and quite a lot of geochemistry, and then just extensive drilling. There was an existing 1996 fixed-wing magnetic survey completed by Aberfoyle that was used for the initial targeting, and this was a fairly good survey with 200-meter line spacing. We supplemented later on in 2012 with a helicopter-borne magnetic survey with 100-meter line spacing and a 35-meter survey drape. And you can see this outlined probably a central area here with a central intrusive or volcanic complex magnetic area, and perhaps even then you can see the remnants of a volcano with these radial flows around the center of the old eroded volcano. So we think this is an older eroded volcano. We started doing some very detailed soil sampling in this area. This is overlays on that magnetic image in the background. You see detailed sampling on 1 to 400 meter spacing. We identified some coincident mag anomalies as well as this copper anomaly shown in this portion, both in this central south area, but also in this northern area up in Leary. And many of these anomalies, particularly in this area around here, turned out to be quite strong multi-element anomalies with copper, gold, and moly. And the first one of these we targeted was actually a strong magnetic anomaly with coincident moly, gold, and copper. And this was the first hole in Humpulau East. Humpulau East, the discovery hole. So the first hole was we hit 414 meters at 0.45 copper and 0.26 grams per ton gold, starting at about 138 meters downhole. We drilled off this small resource with 21 holes, about 15,000 meters of drilling over the period of the next year. Humpulau East is a very classic pencil-shaped porphyry with mineralization centered on a series of vertical multi-phase diorite porphyry dikes with potassic alteration and biotite magnetite alteration with quartz vein stockworks. You can see a typical photograph of this here with a well-developed AB vein stockwork in potassic alteration. Most of the good grade was associated with a early high-grade porphyry, as have been talked about by a few speakers earlier today, and then a later intermineral porphyry, which was slightly lower grade. And then, in fact, the lower part of the system was cut out by a series of late intermineral porphyries with relatively low grade, and this sort of limited to the potential tonnage on this deposit. There's quite a lot of advanced argillic alteration recognized in this drilling of Humpulao East on this west side. So on the left side of this orange band here, there was essentially all advanced argillic alteration, quartz alunite and silicification, and also in some structurally controlled zones that actually cut down through the deposit. The top of the deposit was actually the potassic alteration is overprinted by a low temperature rhyolite smectite alteration. But as I'll show you in Onto, we actually think we hit the top of the intrusions here, and these intrusions didn't breach the current surface. So we drilled right into the top of these porphyry intrusions. Following Humpulao East discovery and the drill out, we completed a bit of reevaluation of the soil geochemistry and magnetics, looking for additional targets. So this is just this was the attempt to do this, and we just laid out these geochemical anomalies on this magnetic background. And in doing so, we identified not only some of these strong multi-element porphyry anomalies associated with mag anomalies, like we drilled in Humpulao East, but we also identified some more subtle copper-only anomalies, particularly this area M here, which stood out after taking out some lithological effects into effect by regressing this with cobalt. And this is some of Peter Winterburn's work. After drilling Humpulao East, which is shown here in this area in D, we then progressively moved down to the southwest, essentially drilling 800-meter holes through the lithocap. We first targeted this area Sorihui, which had a good mag response, and predominantly hit a series of intermineral intrusions, but generally below the lithocap. We then targeted this hole 33 to test another weak mag anomaly in an area with weak geochemistry, but in this case we recognized it was this area was overlain by relatively fresh andesite cover. So we started to drill some weaker geochem anomalies, bearing this in mind. So that hole intersected some weak copper gold mineralization, but for the first time in this drilling at least, some very extensive advanced argillic alteration over at least 250 meters. At the same time, mapping at this stage identified some copper mineralization in small phreatic breccias, some A-vein class and disseminated sulfides in a phreatic breccia in this area here, and also a phreatic breccia with some covellite class with up to 0.6% copper in handheld XRF in this region here. And it was partially this geochem that allowed us to target this, what was nearly a final hole in this program, hole 34, targeted on a weak interpreted mag anomaly below the andesites with some weak geochemistry. And this turned out to be the discovery hole of the Onto deposit. And this is essentially the outline of the Onto deposit as we currently know it. So this hole just tagged into the southeast side. I'll now take you through the Onto discovery program from 2013 to present. This next series of slides will show a much smaller area that's outlined here in this purple dashed lines around the actual Onto discovery. As mentioned, the first hole, 34, targeted a weak magnetic anomaly. In fact, it just turned out to be the overlying andesites, but there was this weak geochemistry and the mineralized phreatic breccias and outcrop that I just described that encouraged us to drill this hole. The hole intersected nearly 400 meters of a relatively unaltered hornblende andesite, and then about 100 meters of quartz dickite, kaolinite, and porphyrite alteration in sediments and breccias, and then an 80-meter thick vuggy residual quartz horizon that was strongly silicified. And it was only beneath this that the mineralization started about 548 meters downhole, and then we made an intersection of 287 meters of nearly a percent copper and 1.13 grams per ton gold within quartz alunite alteration. And interestingly, as I said, all within advanced argillic alteration, and interestingly, all the copper was now occurred as covellite. As I said, the style of mineralization was different. What initially looked like bornite had a blue streak and turned out to be covellite, as seen in this top photograph here. And in the central photograph here, the covellite was seen to be intergrown with a lot of very strong quartz alunite alteration in this hole. And then at the end of the hole, down in this area here, we did actually intersect what were recognizable quartz vein stockwork, even though in this case contained within vuggy residual quartz altered rocks. So this is a section with the early drilling. So hole 34 was like this. The next hole I described, 35 here, and then this is a vertical hole we drilled, hole 37. As you can see, this is actually on this section. This is largely an alteration section. The upper andesites were essentially unaltered to increase dillite smectite at the base here in these slightly more yellowish colors. Then the quartz dickite plus or minus porphyrite, some very minor quartz alunite, and then this very persistent layer of what we call silicic alteration, which is essentially silicified buggy residual quartz rocks. And this turned out to be a very extensive horizon over the top of the deposit, and actually continues at about the same thickness over to the west here. And then, as I mentioned, we did in the base of 34, not in 35 actually, but in 34 we hit at this quartz vein stockwork, which turned out to be an intrusion. So in the end, we did actually start to identify some stratigraphy as well. Initially, that was very difficult because once you got into the advanced argillic alteration, recognizing rock types was very difficult. But essentially, there was this unaltered andesites on top, a series of tuffs and sediments in the central part here, and then underlain by a series of polymictic breccias. And then, as I said, in the base of 35, we just clipped into what turned out to be an early porphyry intrusion. And then this turned out to be a very consistent stratigraphic package with the ongoing drilling. Next hole was 35, which was very similar to 34, other than it didn't hit the stockwork zone. 36 was then drilled to the south and intersected low-grade mineralization on the top of the system, but then passed out of advanced argillic alteration on this side. But the breakthrough hole was really hole 37. This was the first hole to reveal the full vertical extent of mineralization. And this nearly vertical hole terminated in mineralization at 1.5 kilometers and intersected, as you can see here, nearly a kilometer of 1.26% copper and 0.7 grams per ton gold, and ended in quite strong mineralization. This is, of course, a celebration, as you can imagine, but there were still a few skeptics that pointed out there was still the possibility that this hole had drilled down a narrow high-grade structure. After 37, we, of course, we're full of confidence, and we initiated some very large step-out holes. 38 probably stepped out a little too far, and despite quite strong alteration, advanced argillic alteration, contained no mineralization. 41 and 46 on the north and south side respectively were drilled a bit too far out and just started to get into decent mineralization at the end of the holes, but they didn't drill quite deep enough. And then 39 at least showed that it extended to the northwest within this northwest-east trending corridor. Then finally, in April and May of 2014, so nearly a year after the discovery hole, 44 and 45 were drilled at 80 degrees and 75 degrees respectively to the north and south from a drill site here that was at 500 meters northwest of 37. And you can see that both intersected similar grades to 37, over 750 meters of 1% copper and half a gram gold. And this was these were the two holes that finally showed that we had some good good lateral extent to the deposit. So it extended at least 700 meters wide in this sort of northeast southwest direction as well. So this would be the original discovery hole down here, and 44 and 45 here. So these are all the drill holes at least to the end of 1919. There's 55 holes, about 41 if you exclude some redrills and geotechnical holes, etc. And essentially what we defined was a 1.5 long block by about a kilometer wide that extends to at least a kilometer vertically, essentially the base of current drilling, and essentially very consistent grades within this block. It's closed off on the south side and fairly well on the north side, but actually not closed off very well on the southeast and on the southwest side. And you can see the central sort of eastern part of the deposit is still not very well drilled. The table shows some of the key drill results for 14 of the holes. You can see that 2/3 of them, the ones that are bolded here, have intersections of greater than 750 meters with copper between 0.65 and 1.3% copper. And I just highlighted 3 of the better ones in hole 37, 60, and 73. 60, for instance, nearly 1,200 meters of 1.02 copper and 0.55 grams per ton gold. And the other interesting thing to point out is at least half the holes end in mineralization, so they're reasonably good grades at the bottom of many of these holes. I'll also draw your attention to a series of very high-grade intersections at the top of the system. We term this the upper onto part of the system, and I'll show you this in some of the next sections, but typically 10 to 35 meter intersections at 5 to 12% copper, shown here in these couple of examples in these yellow highlights. You know, typically, for instance, in 63 here, we had a 24-meter intersection, nearly 7%. And this is at the top of the deposit, actually in the silicic alteration that I described and will describe, predominantly in this area here. So to the resources, these are the resource figures. You can see them. PT Sumbawa Timur has released these on their website. If you want to look at them in more detail, I'll just skip to the highlighted figures. Onto currently contains indicated and inferred resource of 1.7 billion tons at 0.89% copper and 0.49 grams per ton gold. You can note here that it's actually got relatively low arsenic. Average for the deposit is about 350 ppm only, and contains 15.3 million tons of contained copper and 27 million ounces of gold. I should mention that only the material that falls in two well-defined block cave lifts here, designated, lift 1 and lift 2. Only material in those two block cave lifts was designated as a resource. So all the surrounding material to these block caves is designated as an exploration target, despite the fact that it's probably been drilled off a lot of it at 200 to 400 meter centers. So the exploration target is an additional 600 million tons to 1.7 billion tons at between 0.4 and 0.7 copper and 0.2 and 0.33 gold. This is a longitudinal section showing the drill holes colored for grade. You can see the legend up on the top right here. Also shown are the 0.2 and the 0.3 copper envelopes to the end of 2019, defined by the 41 holes I mentioned. And the remarkable thing about Onto is once you're inside these grade envelopes, the grade is very consistent and very uniform, and there are no real barren rock types within here. And we attribute this to remobilization and redistribution of the copper, and to a less extent gold, into all the rock types, including later porphyry phases that were originally probably lower grade. And this high sulfidation overprint seems to have added copper and smoothed out the original grade variations in this deposit. As I mentioned, many of the holes actually end in high-grade mineralization, for example, in these holes here. And you can see within that 0.3 shell, for instance, we have not really drilled any dud holes in there with low-grade material, and that's still the case actually 1 year later with some more detailed drilling in some of these gap areas. As I'd indicated, showing you from holes 44 and 45, essentially the mineralized volume and grade stabilized after those two holes, and we didn't really increase that volume or grade actually after that time. And it's interesting, if you look then at those 11 holes, the drill program at that time was averaging, adding on average about 1.3 million tons of copper and 2.45 million ounces of gold per hole. So this was and is an extremely remarkable and efficient, drill out of this deposit, and I think it says something about some of the consistency within the grade. As I mentioned, there's a small Onto deposit here. Is this sort of orange shell up here, with these 25 to 30 meter intervals at sort of 5 to 10% copper as covellite. That's not currently part of the existing resource, as it really hasn't been drilled off in any great detail. But there's perhaps potential for 10 million tons at perhaps 3% copper plus in that zone. In the next few slides, I just want to sort of emphasize the discovery at Onto and quickly put on the discovery into context. This is a grade tonnage curve for copper discoveries, both brownfields and greenfields in the past 30 years, with curves for 1, 3, and 5 million tons of contained copper for reference there. It's actually a plot the plot is actually from 2010, but I added the discoveries with more than 5 million tons of contained copper since 2010 in blue. And there's actually only 4 of them. There's Sierra Negra, Timok Lower, Cascabel, and Kakula, which is part of the Kamoa system. As you can see, I mean, I don't want to go over this too much, but as you can see, Alonto falls in very good company, very similar grade to Timok Lower, with only really resolution, Sulfatos and Ogutoyu, parts of Ogutoyu at least, showing higher grades. As I mentioned, this is also likely to grow as if you include that exploration target in these figures, you're likely to increase the tonnage up somewhere between 2.3 and 3.4 billion tons at the grades I mentioned. Alonto also compares favorably if you compare it to existing porphyry copper deposit mines around the world, as shown in these figures from Dave Cook et al.'s paper in Ikonjo in 2005 on giant porphyry deposits. These plots show the 25 largest known porphyry copper deposits based on contained gold and contained copper. And the solid arrow here indicates the position of Alonto based on the current released resource of 15 million tons of contained and 27 million ounces of gold. And the other arrow is just is the in situ resource without any mining constraints at the 0.3 cutoff, and you can see it's considerably bigger. So it compares quite favorably. It's already a giant porphyry deposit with greater than 2 million tons and is probably in the top 20 biggest porphyry deposits ever discovered. And this doesn't really even take into account the 27 million ounces of gold, and you can see it actually would sit within the top 5 if you consider porphyry deposits based on their gold content alone. As said, likely to grow also, as this is essentially based on 41 hole when I plotted this up. Just now looking at some of the geology, I'll take you through some geology and some of the alteration and show you how it relates to mineralization. This is a longitudinal section from northwest on the left to southeast, showing the rock types. Essentially, this would be along the long axis of mineralization, showing the relationship of the mineralization to the various lithologies. The oldest rocks are a series of what we term the older andesites, shown in dark green here. This is cut by a large diatreme breccia with polymictic breccias contained in it, shown here in light blue. And then this is capped by a series of sediments that probably formed in a Maya-type environment, and also a ring tuff pyroclastic, which occurs outside the main vent. This central diatreme is then intruded by a series of porphyries, going from an early in red to an early intermineral in pink, and then a late intermineral shown in orange. The dashed line indicates the 0.2% copper envelope. You can see it's clearly centered on the porphyries, particularly the 2 earliest porphyries, and then extends for considerable distances above into the polymictic breccia, and then a short distance on the side in the polymictic breccias as well. This is the same cross-section for alteration. You can see that those capping andesites are largely unaltered or have illite-smectite alteration, shown here in the olive colors. Underlying that, at the base, there's a quartz dickite plus or minus porphyrite zone here, shown in orange. And then 2 subhorizontal vuggy residual quartz horizons, shown in dark blue and in light blue. And the light blue one is generally very silicified, and this is one we term the silicic alteration. And this is very extensive across the top of the deposit. It's actually a very, very useful marker in drilling. This is then underlain by quartz alunite alteration, shown here in pink. And then going down, you go down into quartz porphyrite alteration, shown here in brown, and then into quartz diaspal porphyrite alteration, shown here in the darker red colors. Again, the 0.2 copper envelope, quite unusual for a porphyry type system, in the vast majority of mineralization, more than 90%, is contained within quartz alunite and quartz porphyrite alteration. This is a quick look in cross section as well, from south to north. Similar to the last ones, you can see the intrusions within the central diatreme shown in light blue. The grades extend above the porphyries into the diatreme breccias. Most holes stop at about 1,000, minus 1,000 level here below sea level. And then recently we drilled one deeper hole down to just over 2 kilometers in this central area here. And as this hole 96 intersected nearly 1,600 meters of 1% copper and 0.4 grams per ton gold, including a high-grade section in this central portion with only 100 meters of 6% copper and 1.1 grams per ton gold. And this bodes pretty well to the vertical extent of this deposit, and the majority of the drilling up until this hole was terminated at about this minus 1,000 RL. Same cross section with alteration, much as I described before. Majority of mineralization contained within quartz alunite and quartz porphyry alteration. And in fact, the quartz alunite shown here in pink is actually the preferential advanced argillic alteration type for the better grade material, in that it's much more porous and permeable, and became infilled with covellite during the later stages of mineralization, as I'll show you in a few of the slides. And some very rare potassic preserved in one hole, slightly off this section on the very side of the deposit. Just before I look at mineralization, it's just worth emphasizing the intensity and scale of advanced argillic alteration at Onto. The advanced argillic alteration encompasses at least 2 kilometers by 1 kilometer and extends to at least 1 kilometer vertically. In fact, probably more like 1.5 kilometers vertically, essentially to the base of the current drilling. And once you're in that alteration, it's extremely impressive, and the original protolith is very difficult to recognize in many cases. And I'll just show you one example of this photograph. You can see reasonably good textures here, good porphyritic textures in what actually is, we call a late intermineral porphyry. And yet you can see 99% of this rock is made up of only silica, aluminum, sulfur, iron, and lesser amounts of potassium. And this is totally consistent with the petrography we did on this sample, where it's essentially composed of quartz, porphyrite, alunite, and pyrite with lesser amounts of diaspore and zunite. So even in what you would grab as one of the least altered samples in this deposit, you can see the alteration is extremely impressive and intense. Oh.
Is everything okay, David?
Seem to have a bit of a technical hitch. I'll just give it 1 second, see if it responds. Oh, maybe here. Maybe it's still, sorry about that. Just looking at the mineralization now, hopefully, if the slides continue. This is the earliest type of mineralization that we see in Onto. It's essentially a classic porphyry style alteration with potassic alteration, A, B, quartz vein stringers and magnetite stringers with chalcopyrite as copper as chalcopyrite and bornite pyrite. And to date, this is only a very, very small part of the resource, less than 10%, and is largely restricted to one hole. What is remarkable at Onto is how this typical porphyry style mineralization with bornite and chalcopyrite pyrite, with the associated, magnetite and quartz vein stockworks, is transformed or progresses into a high sulfidation style, epithermal style, which is dominated by covellite and pyrite. So this is the potassic style alteration I just showed you with bornite, chalcopyrite, some late D veins here, and a chloritic overprint. You note the grades. It's transformed into a rock in which obviously the quartz veins are preserved, but all the matrix is turned to quartz alunite. You can see a lot of hematite in this particular case, so there's a lot of relic potassic alteration in this sample. To much more intense quartz alunite, porphyrite, and all this brownish and white material here is porphyrite and alunite, but again with the quartz vein stockwork preserved. To very intense quartz porphyrite rock in this case. And in the extreme case, buggy residual quartz, in which a lot of the a lot of the minerals are actually stripped out of the rock during a lower temperature alteration around 200 degrees, and you're just left with essentially residual quartz and the original quartz vein stockwork. Interesting thing in Onto is that the grades during this process don't change that much. You know, in the early porphyry, it maintains its grade of around 1% copper and maybe 1 grams per ton gold, and it doesn't seem like this remobilization and advanced argillic overprint was actually destructive. Seems more like there was local remobilization, and the grade didn't change that much, but the grade is actually smoothed out within these areas. What you don't see in the potassic alteration are a lot of high grade intersections, whereas in the advanced argillic hosted material, there are a lot more high grade intersections. So there's been a potential upgrading during this process. As I mentioned, during within the porphyry hosted part, there are certainly some high grade intersections. So not only does covellite replace the original mineralogy, which would have been chalcopyrite and pyrite, potentially, say, for instance, in this B vein in this left-hand photograph here, the rock is actually leached out during later advanced argillic alteration, and you're left with open space between this quartz vein mesh, essentially. In the right-hand side here, probably at least 50% original veins, and then all that pore space between the veins, interstitial space, is actually filled by covellite, which is all this dark material in these two photographs, and in some cases also native sulfur and pyrite. This is typical of the mineralization process in the overlying polymictic breccias overlying the porphyries. This is a polymictic breccia in which the fragments are replaced by quartz, alunite, porphyrite, sometimes dickite, so you get these sort of patchy textures. During later alteration, the alunite is actually removed here, so all this wider material is removed. You're left with bugs, and then these bugs are filled in by, in this case, by pyrite and covellite, and quite commonly also by native sulfur. Some other examples, similar, disseminated pyrite and covellite, in this case with some sort of geopedal structure, filling in all the late bugs. In this particular case in the center here, very strong replacement of covellite and all the open space bug fill. And then you can just see on the right-hand side some details with covellite intergrown with alunite and native sulfur in these bugs. And then the last stage within the high sulfidation is discrete veins and replacements. Often these veins are up to 1/2 meter wide, and they occur particularly in the polymictic breccia and in the late intermineral porphyry, and seem to upgrade these potentially lithologies that were originally lower grade, perhaps. Don't have a lot of time to go through this. The age dating that we completed on the Onto deposit is really interesting, but the key takeaway here is the host rocks shown here in this sort of green are about 800,000 years old. The porphyries come in about 600,000 years old, so no millions involved here, just thousands. And then the mineralization, which has been dated by rhenium, osmium, or moly in both the B veins and the later high sulfidation style, comes in between 440 and 350,000 years old, and overlaps to some extent with the porphyry emplacement. This makes Onto by far the youngest major porphyry system in the world, and it's an order of magnitude, younger than El Teniente and Grasberg, and the only deposit that comes close to it is Octedi at about 1.3, as was indicated earlier in the talks today by Stuart. And this clearly puts some constraints on how quickly these systems can form. Onto formed very young, and also probably formed within a much tighter period within that 400,000 years, obviously. Interesting, the alunite dating we've done indicates that some of the alunite alteration may even predate the intrusions or occur at the same time, very early, and then continues essentially to the present day. So just quickly in the last few minutes or last minute, take you through a series of slides that quickly outline how we think this deposit formed. The earliest rocks are these early andesites. Some interflow horizons and bright red church are shown here, and some hyaloclastid textures shown here in this photo indicate some of this sequence is probably submarine. It then probably became emergent with a sequence of mixed plagiapheric and vesicular basalts to basaltic andesites, occurring probably from somewhere between 5 million to perhaps 1 million years ago. At this stage, we think there was some early porphyry development, lithocap development, and perhaps this porphyry system was aborted by the diatreme formation that occurred just after this. And we know this because we see we see fragments of vein porphyry and fragments of advanced argillic alteration quartz alunite and buggy residual quartz within the next diatreme breccia that I'll show you. This is the diatreme breccia, the major phreatomagmatic eruption. So you got a polymictic breccia that filled this vent and a pyroclastic tuff ring that's not shown here that occurs outside the vent. And a huge variety of clasts, from juvenile clasts to sediments to advanced argillic altered clasts, and some vein porphyry clasts in some cases. Series of sediments developed on top of this. And again, I draw your attention to the age here, about 800,000 years ago. And it's actually quite possible that early hominids that inhabited these islands from about 1 million years on wandered around these steaming lakes and actually witnessed a major porphyry deposit forming or starting to form about a kilometer below. It was capped by a series of andesites up to perhaps 1.4 kilometers with topography. And then a series of intrusions intruded the central portion of the diatreme, the early porphyry with the good grades, as I mentioned, about 1% copper, 1 gram toll, high intensity veins, lots of gusano, wiggly type veins in the top of the carapace, early intermineral porphyry with slightly less well-developed veining and slightly lower grades. And then both these porphyries develop a well-developed quartz vein stockwork in the top 300 meters of the porphyries. And then a late intermineral porphyry that intrudes its much lower grade and shows some of these more recognizable textures. At some stage after those porphyry, or even perhaps as I mentioned slightly before, this was overlapped and enveloped by quartz porphyrite plus or minus diaspore alteration that extended down to the porphyries and to the base of the capping andesites. And then there was a later advanced argillic alteration typified by the quartz alunite that went down into the system with intense alteration extending down to at least 1 kilometer, or at least the base of current drilling. And this sort of slide shows the final outcome of these processes of mineralization. This is the 0.3 copper shell, as you can see, arranged around the top of the porphyries and with a close relationship to the AB quartz veinlet stockwork. But in this case, totally overprinted by quartz alunite and quartz porphyrite, shown here in these yellow colors. So just in summary, Onto is a very large grassroots porphyry high sulfidation epithermal discovery. Current indicated in inferred resources are about 1.7 billion tons at 0.89% copper and half a gram per ton gold, containing 15 million tons of copper and 27 million ounces of gold. The copper fairly uniquely occurs as only as covellite, and this is reflecting high sulfidation conditions as the fluids cool in these advanced argillically altered rocks. And there's a lot of constraint on how these porphyries formed, in that this porphyry is extremely young and formed rapidly within the last 500,000 years, probably within a much tighter interval within that 500,000 years. Thank you very much.